The three remaining tabs are the main components of the PMT. As you recall, the PSI was divided into two parts. Part A, site and transport characteristics, and Part B, source and management characteristics. The PMT has been reorganized. It still identifies the areas where high transport potential and high source are present, but it does so for each of the major P transport pathways. Particulate, P associated with soil particles eroded from the field. Runoff, dissolved phosphorus in surface runoff. And subsurface, dissolved phosphorus lost through subsurface pathways. Let's look at the particulate page. On the top line of each PMT page are the transport factors. For this page, the key component is the Russell A erosion value. The appearance may vary depending on which Russell method was selected back on the field page. This field shows an example of the appearance when the first Russell method was selected. The LS, C, and P factors are automatically carried over from selections made on those pages. Moving to another field, this shows the appearance when the second Russell method is selected. You would type in the LS, C, and P factors from lookup tables directly on this page. And this field shows an example of the third Russell method. Simply type in the Russell A value either from a conservation plan or from Russell 2 output. But whatever method you use, the Russell A value is the key transport factor. The phosphorus source on this page is represented by the PFIV value, which is automatically calculated from the lab phosphorus entered back on the field page. The management component is calculated by selecting two factors: the distance to surface water and the buffer type. And then these two are multiplied together to give you the combined distance buffer factor. And then the particulate P transport risk is calculated by multiplying the factors on the right side of the screen. So the transport factor times the source factor times the management factor, and it's scaled by multiplying by 0.1, gives you the P transport risk for the particulate pathway.